Hey y'all, let's cover lesson 15, solving application problems. So application problems are what you would consider word problems. In our next class in Math 1500 problem solving, you will be doing a lot of word problems. If you struggle with the comprehension aspect of it, please slow down and don't have any distractions around you. That's a big problem with the word problems that I'm saying, is that there's too many distractions happening and you're not able to just concentrate on what it's actually saying. Okay. So recall our procedure for solving application or word problems. Number one, you got to set up a variable dictionary. Set up a variable dictionary. All right. Number two is to set up an equation that models the problem. Okay. That models the problem. All right. Number three is solve the equation. All right. Number four is to answer the question. So this is a big part for me. I'm doing this with this class because I require it now to get you comfortable and in answering the questions in this manner, so you're not struggling with it once you get to the next class. So when you answer the question, I'm going to answer the question. There's things you need to look at. You need to make sure you give me a sentence, correct units, rounding. You need to check to see what you're supposed to be rounding to. And does it answer the question? Okay. Does it not answer the question? And does it answer? Does the answer make sense? Does it answer the question? Check yourself. And the five is look back and check. And that's, to me, part of it. Look back at the original question and see if the answer you gave makes sense. Look back and check. All right. The next one, we're going to let K represent an integer. So the next consecutive integer is what? Okay, so what if I say the numbers 1? All right, what's the next consecutive number after 1? It's 2. How do we get from 1 to 2? We add 1. So if we say that an integer is x, now I'm writing it up here just because I need space. Say we have an integer, let k, oh, it's k. We're going to let x, so I'm being difficult. Let x represent an integer. Then the next consecutive integer is, well, to be this one would be x plus 1. What would our next one be? 1, 2, 3. So how do we get from 1 to 3? From 1 to 2, we had to add 1. From 1 to 3, we have to go 1 to 3 is adding 2. So then the next consecutive integer is x plus 2. How do we get to the next one? 1 plus 3 is 4. So then the next integer is 3. Okay, so the next consecutive integer is x plus 1. All right. The three sides of a triangle are consecutive integers, and the perimeter is 72 inches. I need a draw. All right. The three sides of a triangle are consecutive integers. That means these, how many? Well, we have three sides, so we have to have three consecutive integers. So if we let one be x, the next one would be x plus 1, and the next one would be x plus 2. Those are the three consecutive integers. And the perimeter is 72 inches. So the perimeter is, I'm going to write perimeter, is 72. Okay. So to find the perimeter of any polynomial, you have to add up all the sides. So for us, to add up all the sides, we would have to go, well, x, the perimeter, I'm going to do this, perimeter is equal to side 1 plus side 2 plus side 3, just to show you what you have to set up. So for us, we know the perimeter is 72, so I can plug in 72 to substitute it for the perimeter. 72 is equal to, side 1 can be x, side 2 would be x plus 1, and side 3 would be x plus 2. Okay. Well, we can add up all the x's. 72 is equal to 1, 2, 3 x's plus 1 plus 2 is 3. All right. Well, we've combined all of our like terms. Now we need to isolate or solve for x. So to do that, I need x all by itself on one side. So I'm going to subtract 3 from both sides, and I get 3x on one side and 69 on the other. All right. Who's attached to x and how? 3 is attached by multiplication. The opposite of multiplication is division. So we're going to divide both sides by 3. So this becomes 1. So there's x is equal to, it looks like 23. Well, there's one side. It says find the measure of each side of the triangle. Well, one side is 23. I don't need to square that. So if the sides, need to give an answer in complete sentences. The sides are, what do I need? I need a sentence, correct units. There is no rounding on this one. And does it answer the question? So I'm writing my sentence. I need some units here. What is my units? Inches. So there are the sides are 23 inches. What's the next one? 23 plus 1. Well, x plus 1 would be 23 plus 1, which is 24. 24 inches. And we've got x plus 2. So that's 23 plus 2 is 25. And 25 inches. All right. That covers it all. If you have any questions, please let me know. Okay. Oh, this one's different. So the last one was consecutive just integers. All right, consecutive integers. So the next one, it says let k represent an odd integer. So, okay, that means I'm just going to let it be x or k. It doesn't really matter. I think they are using k, so I'm going to try to be consistent in that. I would like to use this space right here for this discussion. Just please bear with me. So if k is an odd integer, well, the number 1 is an odd integer. So I'm going to just use that. I'm going to use 1 as an odd integer. So what is the next consecutive odd integer? 2 is even, not that one. So it has to be 3. Okay, 1, 3, and then what's the next one? 5. What's the next one? 7. Okay, great. So if we're going to let's go with k this time, k be an odd integer. Great. How do we get from 1 to 3? To get from 1 to 3, they had to add 2. So to get to 3, it's going to be k plus 2. Okay. How do we get from 1 to 5? 1, 3, 5. Well, that's going to be k plus 1 plus 4 is 5. So the next one's going to be k plus 4. How do we get from 1 to 7? That's plus 6. So the next one's k plus 6. So what I'm going to tell you here, and this is going to be both for even and odd integers. If you let k represent an odd or even, we could do the same thing with 2, 4, 6, and 8. Your consecutive odd, this right here is going to represent your consecutive odd and even integers. Make sure you have this for your note card. You're going to want this information. It's very important for both of these. Okay. All right. So the length and width of a rectangle are consecutive odd integers, and the perimeter is 160. I need to draw a picture. So this is a rectangle, and the length and width of a rectangle. So we've got, okay, let's go with length and width are consecutive odd integers. Okay. And the perimeter is 168 centimeters. So if we're going to let one be K, then that means the other one has to be K plus 2 because they're consecutive odd integers. And how do we find the perimeter of a polynomial? We add up all the sides. So perimeter is equal to 168. I'm going to write centimeters just so I don't forget my unit. And let's do that. So perimeter is equal to side 1 plus side 2 plus side 3 plus side 4. All right, I'm going to substitute where the word perimeter is or the number 168. Side 1, well, if this side's K, then this side has to be K. If this side's K plus 2, this side has to be K plus 2. So side 1 can be K, side 2 is K plus 2, side 3 is K, side 4 is K plus 2. 1, 2, 3, 4 Ks. 2 plus 2, this is just combining like terms or similar. I can't combine anything else. So now I need to isolate K, get it all by itself on one side. So subtracting 4 from both. And we get 4K is equal to 164. 4 is attached to K by multiplication, so we have to divide those sides by 4. And we get 164 divided by 4 is 41. Okay. So that's not our answer. It says find the length and width of the rectangle. Okay. Well, the length is 40. Well, what did we do this for? Yeah, the length is K. So it's 41 centimeters. And the width is the K plus 2, which is 41 plus 2, which is 43 centimeters. Now, I need to go back and check myself. I've got a sentence. There's no rounding. I've got correct units. And does it make sense? So if the length is 41 and the width is 43, does 41 plus 43 plus 41 plus 43 equal the perimeter of 168? That's checking. This is a check. 6, 7, 8, 4, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yep, they add up. So works great. Let's go to the last one. Q inherits $10,000. No, it's not the last one. $10,000 and decides to invest in 2 different types of accounts. Okay, he has a savings account paying 2% interest, all right, and a certificate of deposit, otherwise known as a CD, paying 4% interest. He decides to invest $1,000 more in the certificate of deposit than the savings. So find out the amount he invested in each account. Okay, well, let's look at this. We've got types of account. And we've got the amount that he's investing. So we've got a savings and a CD. And then we will have a total of his savings. All right. So if we say that he puts the amount of X, because we don't know how much he's putting into each. We can figure it out though. We say he's putting in X amount in savings because we don't know that value. Then whatever this is, how would we do that? If I said that I'm putting in $4,000 into an account, let's say This is just my, this is just my thing, how this is going to work. This is my trying. This is me mathing. I'm trying to figure this out. So if I put in $4,000 into a savings account, how much, I need to say that this next one is 10,000. The totals, the two of these added together will give us 10,000. So, nope, that's not how I'm going to do it. That means the next one, I would add 1,000, right? He decides to invest 1,000 more in the CD. So that would be 4,000 plus 1,000. So how could I represent that here? So if X is 4,000, that would be X plus 1,000, right? And the total he invested was 10,000. That we do know. So let's make sure we've got this in here. He inherits $10,000, decides to invest in two different accounts. Savings account paying 2% interest, and a certificate of deposit paying 4%. He decides to invest $1,000 more in the certificate of deposit than he does in the savings. Find out the amount he invested in each account. Okay, now we can do this. So if we add up the amount he invested in the savings, plus the amount he invested in the CD, the total should be $10,000. Right? The savings, let's say he put in X, the CD was X plus 1,000, the total would be 10,000. So that's 2X plus 1,000 is equal to 10,000. We're going to subtract 1,000 from both sides just to isolate X on one side. 10,000 minus 1,000 is 9,000, and then divide both sides by 2. So X is equal to 4,500. That tells me that Hugh invested $4,500 in savings. And, how do I find out the other one? X plus 1,000. Well, X plus 1,000 would be 4,500 plus 1,000. And $5,500 in a CD. That is my answer. So up here, this was just me trying to show you that if he invests 4,000 and then he adds another 4,000, trying to create this piece. Don't be afraid to just pick a number to help you understand it. If you didn't need to do that, that's great as well. All right. So let's go back and see if we've answered the question. Find the amount invested in each account. So $4,500 in savings and $5,500 in a CD. Did we even check to see if those add up to 10,000? I haven't even checked that yet. Let's check that. Does 4,500 plus 5,500 add up to 10,000? 1, 2, 9, 10. Yes, it does. We are good. Okay, cool beans. And the other piece of this, do not forget your unit. We've got the sentence. It makes sense. The numbers are working out, but don't forget your dollar sign. Very important. All right. Jose cracks open his piggy bank and finds that he has $3.25, all in nickels and dimes. Ooh, I like this one. He has 10 more dimes than nickels. How many dimes and nickels does he have? All right, let's just start by writing what the different types are that he's dealing with, the number, and the value of the coin. All right, he's got a nickel, or he's got nickels, and he's got dimes. And then he's got a total. Nickels are worth, well, 5 cents, and dimes are worth 10. So let's go in here. It says cracks open his piggy bank and finds that he has $3.25. So $3.25. All right. All in nickels and dimes. So the 2 here have to add up to 325. He has 10 more dimes, 10 more dimes than nickels. So how would we write that? We would need to know how many nickels there are. So if we let X equal nickels, then 10 more than, remember the than flips it to X plus 10, and we know the more means add. So we have nickels and 10 more nickels, or 10 more dimes than nickels. So that's what that's showing. All right, now we need the value. So when you're looking at a value of something, and I'm just choosing a random number here, the lowest number you need to round to in money is always, always, always the penny. The penny is the smallest coin or the smallest currency that we have in the United States. So we always need to represent up to the penny. And in this case, the 5 could be representing a penny, 5 pennies or a nickel. It's the lowest currency. Okay. So we need to go all the way over there. And we know that a nickel is worth 5 cents. That's a nickel. And a dime is worth 10 cents. Okay. So to write that, it would be X plus, let's see, we'd have to do the value. X times 5 cents, 0.05, because that's what the nickel is. And then the X plus 10 would have to be multiplied by the value of the dimes, which is 10 cents. Remember I told you this plus this is equal to this. Okay, so we're going to set that up. So X times 0.05 plus X plus 10 times 10 cents. And this together is going to give us $3.25. So let's clean this up a little bit. 0.05x plus this has to be distributed over the binomial. So that's 0.10x plus 100 is 10 times 0.101. Yeah, be 1. All right, and that's equal to 325. We can combine like terms. And now let's isolate X. $2.25. Okay. And then I need to divide both sides by 0.15. Ripping out the calculator for this one. And that is 15. So X equals 15. Does that make sense, what we're doing here? So that means he has 15 nickels and 15 plus 10, which is 25 dimes. All right. So, I don't have a lot of space here. I want to check this first. 15 times 0.05, just to make sure our numbers work out. 15 times 0.05, and then we have 10 more than that. So 25 times the dimes. I just want to make sure these add up properly. 15 times 0.05 is equals 0.75. 0.75. And then this is 250. So 8, 9, 10, 11, 12. So that's $3.25. It works. Great. All right. Now we need to provide a sentence. So how many dimes and nickels does Jose have? He has 15 nickels and 25 dimes. There's no units here. Actually, the units are the words nickels and dimes, but we're not providing any monetary value for it. And I provided a sentence. There's no rounding, so we're good to go. And it makes sense because I checked it. All right, a large children's organization purchases tickets to the circus. So expect to see word problems on this next exam. There will be word problems, and the ones that you're seeing here are probably going to be on the exam. So you need to be comfortable with working through these. All right, so be prepared for all of them. A large children's organization purchases tickets to the circus. The organization has a strict rule that every 5 children must be accompanied by 1 adult guardian. Hence, the organization orders 5 times as many child tickets as it does adult tickets. Child tickets are $3, adult tickets are $6. If the total cost of tickets is $4,200, how many child and adult tickets were purchased? Well, let's set up a little thing to help us here. We've got the types of ticket. We've got the number of tickets. And we have the value of the tickets. We've got a child's ticket. And we've got an adult ticket. And then we've got the totals. All right. Total cost is $4,200. That goes there. We do not know this. Every 5 children must be accompanied by 1 adult. So there's 5 times as many children's tickets as adult tickets. So if we let adult tickets be X, the children's tickets are 5 times that, which is 5X. Okay. The value, they say the children's tickets are $3. Okay, so that would be $3 times the 5X. And then the adult tickets are $6. So we're going to have $6 times X. Well, that's 15X. And that's 6X. If we add these two together and set them equal to 4,200, we can find out how many tickets for each. Okay. So 15X, the value of the child's, plus the value of the adult is equal to the total value. So to set that up, it would be 15X plus 6X is equal to 4,200. The terms are alike, so we can add them. That's 21X is equal to 4,200. Divide both sides by 21. And we find out what? 4,200 divided by 21 is 200. And what is X? We have to know what X is. X is the number of adult tickets. So if there was 200 tickets sold here, how many children's tickets were sold? Well, that's 5 times 200. 5 times 200 is 1,000. All right, so what is the question? How many child and adult tickets were purchased? All right, before I write my sentence, I want to check this real quick because I'm saying 1,000 times 300 right here. It's 200 here. Let's do the 200. 6 times 200. $6 times 200 is $1,200. 1,000 is the total for this. 1,000 number of tickets times $3 is $3,000. That is $4,200, and that checks out. So that's good. Now we can write our sentence. Okay, so how many child and there were 1,000 child tickets sold, tickets, and 200 adult tickets purchased. The units are child tickets and adult tickets. I don't have to round, and it makes sense because we did our checking. And that is it. That is it for lesson 15. That's also the last lecture before exam 2. Please let me know what questions you have and do the homework as many times as you can until you can do it without the lecture videos or without the videos and without notes. And then once you know it that well, then you're prepared for the exam. Right. Let me know if you have any questions.